Welcome, everyone. I am Diego. I am one of the leads at the Selenium project. I am one of the folks that oversees everything related to open source at Sauce Labs, and I am part of the team who engages continuously with thought leadership, education, and we find always ways to help our customers be successful at test automation, and then hopefully that reflects on their Sauce Labs usage as well. So today we have, it might be a simple topic, but it's a topic that we don't see as often as I wish. Um, so the idea for this presentation today is that as many of us, we have like our bookmarks in our browser. When you see something interesting, at least that's the way I do it. I keep the links in a directory in the bookmarks. And there was this link from the Martin Fowler website. Somebody wrote an article about the test pyramid, but more focused on like how would you actually do that layer by layer, and how would that reflect in your code base and in your practice. So I thought, even though this is an article that has already some years, I took an approach where I reflected on the idea, and then I updated that. And I thought this was an interesting topic to share. So yeah, if you have any questions, any comments, because some parts here are mostly like an opinion based on my experience and the conversations I've had with customers. But if you have opinions, or maybe you think something else would go better instead of what I'm saying, please feel free to comment or ask something. We can also open the mic for you if you want to, contribute to the session. Right, so let's dive into it. Let me just organize my screens here so I can see if someone is asking something. But you can also leave the questions and we can get to them at the end of the session. Right, so as the test pyramid as we know it, it has a foundation. But more than a foundation, talking about the base, is that the goal of having a test strategy in general, and the test pyramid is some sort of a strategy, is that we all know that testing is an investment. And the idea is to move forward as fast as possible without breaking things. That's one of the principles of the test pyramid, to actually move forward, go step by step, have this opportunity of feedback that happens in a loop, that you can actually see that your things, your changes are being successful, and then you move forward in a confident and in a trustable way. Normally, we do this through what we call continuous integration and continuous delivery. And the idea of all this session and the test pyramid is to actually have software and our tests in a way that you can always execute them, you can always deploy them. That's the main principle of integration and deployment in a pipeline. So one of the core things here is that we all know the test pyramid, that the lower you go is the faster you can actually run those tests. And the higher you go, tests get more dependencies, get more things involved, and therefore they get slower. A different way to see this is how Simon Stewart wrote it in a blog post of, I think it's 2012, when Google used to do the Google testing blog. He actually wrote that in Google they have three types of tests: small, medium, and large. And you could basically map that to the testing pyramid, because the basic test, the small one, or the unit test, is a type of test that doesn't use anything but just like the memory. It doesn't have any IO or doesn't have any network interaction. That's the basic test. Then you can have something like a middle test that they're allowed to have some sort of like interaction with the memory of the machine, and with the disk of the machine. So some IO and some memory. And ideally, they should last a few milliseconds or up to a couple of seconds. And then you have like the big type of tests that it doesn't need to be a UI test. It could be like an integration test or an API test that has different dependencies. And these ones are allowed to have, memory, IO, so access to disk, and network. So it's the same idea of the testing pyramid. And we all know this, but unfortunately, what we see often, actually, I see this on a regular basis. We have customers that come to us and tell us, I have all these tests and it's just very low. Like I cannot really guarantee the quality of the application because it takes me quite good time to run all these tests. And this is the famous software testing anti-pattern of the ice cream cone, that basically you flip the pyramid, you have way more end-to-end tests than actually the middle layer and the lower layer. So I think this was valid when we had like these monoliths that the only way to test an application was through the UI. But now that we have APIs, we have more splitted code bases, then this is possible. I don't know. Please write in the chat if you actually have this pattern or if you have seen it, and maybe you can share it if you have actually gone after it in a way to maybe flip it, and if you were successful or not. Right. So if feel free to write that anytime you wish. What I'm gonna do now is I'm gonna navigate through the presentation as if I was reading the blog post to you. So you don't need to actually go and read it because it's extremely long. So the idea of what we're going to talk today is that let's imagine that we have a website, we have a service like a backend, and then this backend has dependencies. It has a database and it also makes calls to a different API. If you zoom in into the backend, then you would see that the backend has different things like a controller, which is what orchestrates what talks with what. And then you have a client that talks to an external database, and you have another client that is called a repository that talks to a database. So yeah, this is our basic system, and this is how we're gonna like cover this topic in the next slides. So the base of the pyramid, which we all know, hopefully, is that we have unit tests, right? And the idea of a unit test is that we have some logic that we test in isolation. It could be backend, it could be front end. It doesn't need to be only, like APIs and things like that. But the characteristics is that it's a small test. It's very fast, it's very stable, and most of the time these tests are owned by the developers. So we have two types. That's a typical distribution of unit test. One is like the type of test that is mocking everything. So instead of actually interacting with the dependencies, it mocks the dependencies. And there are the sociable ones that actually interact with those dependencies. And depending on the speed and the requirements for the setup, they then move, instead of being a unit test, to be more like an integration test. What do you folks have in your code bases? Do you get familiar with unit tests, or do you just like look at the API tests and UI tests? Would be cool to see some comments in the chat and see if you are actually familiar with this type of tests, or you focus on the more higher layers. One interesting thing that applies to every single test, no matter if it's a unit test, an integration test, or an API test, or like a Selenium, Playwright, Cypress test, is that this type of structure applies to every single type of test. So regularly, when you want to test something, you set up the test by arranging something like having data ready, so arranging it. And then you actually call, or you make an invocation to the thing you want to test. And when you have done that invocation, you get a result that you assert on it. So this is a typical premise that you use for testing, which is arrange, act, and assert. And there is a good conversation about, if you should use BDD or not. For example, the given, when, then, it is exactly the same thing as act, arrange, act, and assert. So in this case, this is the most important part of testing, automated testing for me, because usually these are the 3 steps you follow to have a successful test case. And when you start to have like combinations of act, arrange, act, and assert, and maybe you do like some sort of like arrange, act, and then arrange again and all that, you already can see that your test is not having a good shape, because tests should be as focused as possible. And therefore, if you have a different way of combining these different arguments, you are probably setting up yourself for failure. This is actually like a basic example of a unit test. Let's see let me turn on the pointer here. So in this case, we have interacting with the API service. So for example, here, this is a service that you send a last name, and then if the last name is known, it replies with saying hello, last name. And if it doesn't, then it replies, who is this? So there are the patterns, like you have the arrange, you have the different data that is going to be used, you have the act, that here you're actually invoking the code. And after that, this is the actual code that does that. And this on the right part, this is the unit test that is actually testing the left part, which is the code that is doing that. So here you have different tests. One is the happy path and one is the ugly path. And in the first part, you have here the arrange. We're setting up data, which is a person, and then is the given. So given this person, I invoke the method, and then I assert that this is happening. So it's very simple. It's very similar to what we do in unit test, in API testing, for example. And when we have a good shape of our page objects, it looks very similar as well. Let's make a pause to read Nilu's comment. My engineering team in Retros mentioning that integration testing takes a lot of time. Any tips on that? I'm not a technical person, by the way. I collaborate with the team as a quality coach. Yeah, actually, in the following slides, there is a tip for that. Well, I think there is a tip that should work for you. But if you want to give more details in terms of what lots of time means, or if maybe you have found out why it takes a lot of time, probably the tip we're going to give you should work for you. While I will advance with the slides, we're going to talk about the middle layers. Back then when the test pyramid started, we were thinking about the middle layer as, the integration tests or the API tests that were done for backend services. But today, with all these new web frameworks, you can actually have component and other type of testing as middle layers in a web application. I think this is the most misunderstood layer, but I think it's the most important one, because you can still have tests that are pretty smart and pretty fast without actually opening a browser. So the idea is that you can combine these tests to refine the pyramid, refine the shape of it, and then leave the most valuable ones as a complete full end-to-end tests. For this context, we're going to consider 3 types of tests that we have in the middle layer. So one is visual, and I will explain why. then service and communication tests. The middle layer about visual testing comes to this point, because before we were only able to test a web application until it was completely built and deployed, right? That is not true anymore. So, for example, if you use React, React uses a storybook intensively, and a storybook is just a way to develop and test the UI components of a web application. And it is actually possible to deploy and render these components as if they were a website without actually building the whole website. So it's possible to take those components, take a screenshot of them, and visually compare if they're actually working and the changes that are happening are not affecting the way the application should work in the end. So one option here to improve the tests and balance the complete pyramid is to take this layer, purely plug it. You can connect like Playwright and visual testing at Soft Labs, and then have a way to make validations a bit faster, and you don't need to wait all the way until the application is deployed and built to verify if many things are working. So one tip in terms of integration testing, I hope maybe you're talking about the web application, is that you are able to verify how the application should look already at this level. Another way of doing that is using component testing. So this is the web application is usually built by modules, and these modules are the components. So the user area has different components, whatever renders the data and so on. You can actually write tests that don't need to render a browser. So you can alleviate this middle layer and already cover some of the possible places where a bug might squeeze in. And therefore, you're going to be balancing the whole strategy. So Nilu, if you have more data in terms of like what is taking longer in the integration testing, just let me know, and then we can also tackle that. So if you want to see the examples for visual testing with Storybook, just jump here. We will share this link in a moment, and then you can actually check them and go through them. Here is the next part. I think it's one of the most important ones, which is the API test. Most of the web applications rely on APIs, and those APIs rely on databases or message queues and so on. So these ones are extremely important. And what happens very often, at least that's what I have seen with customers, and also when I was working as an automation tester a couple of years ago, is that we had duplicated tests. This means there was a test at the API layer doing the whole workflow with different variations, and we had the same test at the UI level. This basically meant that, well, API tests were much faster, but at the UI level, we were running way too many tests that could be like simplified. So instead of having 15 or 10 different variants of a workflow, of a user flow, we actually took the 2 or 3 more important ones, but instead of like, just running those 2 or 3, we said, okay, now we have like 2 or 3 or 5 important tests for this user flow. What we're gonna do is to run them in different browsers, in different operating systems, also in a mobile device. So we make sure that the user flows work everywhere. And then we are also covering the other cases at the API level. So that's a much smarter way to use resources like Sauce Labs and so on. So instead of like running 100 tests every night, you can run maybe 30 or 40 tests more often in a wider range of browsers. This is like a quick example of an integration test. So this is the test that is actually verifying that integration with the database works well. Please note that it looks very similar to the unit test because it is doing basically the same thing. So it's doing an arrange of the data we're going to use. It's going to be saving this into the database because this is the arranging of the test, and then it does it calls the method it wants to test, and at the end is actually doing the assertion. I'm going to make a pause to read what Nilus is asking us. In our sprint planning sessions, we've noticed that story point estimates often don't account for the effort required for integration testing. While this might seem like a general oversight, I'd love to hear your insights specifically from a consultant's point of view. Are there any strategies or best practices you've seen work well across teams to ensure integration testing is appropriately factored into estimation and planning? I'm hoping to take back some practical ideas in our team. Thanks. Yeah, I mean, we're sharing we're not sharing the deck, we're sharing the video after a few days. I have one more extra question for you. Like, can you describe what is integration testing for you? So then we can give you a tip at the end of the session. Okay, let's go back to the slides. And we have an example of an integration test for the API. As I mentioned a moment ago, the structure of our system is that our backend also has a call to another API. And what is happening here is that this integration has to be tested. We assume to some way that the data is going to be always valid, and we want to verify that the data we get matches completely well into what our logic is doing. So in this case, we're using a mock. We're going to mock the external API because we don't want to run external APIs to run our tests. And then in this API test, it's mocking the path. It's saying whenever you go to this path, reply with this type of content. This is something you can today do in the same way. If you want to mock the APIs in your browser tests, you can do this with Selenium and the CDP or by the integration, or you can do this with Playwright with their integration with CDP as well. So this is the arrange. Here it's fetching the weather. This is the act, and here it's doing the assert based on the reply, and it's just asserting that the weather says raining. Okay, so one tip that might be useful for Nilu and for all of you, if you have several like a good amount of backend services, different APIs, because that's what used to be in a huge trend a few years ago, and in some cases still. So you might have many different APIs, and the web application is talking to those APIs. So what happens here is that there is some sort of, consumer and producer of information. In this case, have a look at contract testing. Because what happens when you have integration tests that have a lot of dependencies, you need to start all those dependencies in order to run those tests. It's a much faster way to assure that the integration is working by using something like contract testing. This is basically a way to say, I'm a consumer, this is what I expect from you as a provider. Here are my tests that, if you run them, will assure that whatever you're producing is good for me as a consumer. And all consumers create tests for the producer, and the producer runs those tests whenever there is a change. That is the gist of it. If you haven't had a look at it, check it, because if you have this component as an extra part of your strategy, your UI test will be usually much more stable. Let's go to the top of the pyramid. I don't know if anyone has a comment or a question so far. Otherwise, this will be actually the fastest part, because I'm sure you all know what I'm going to be discussing in a moment. All right, so end-to-end testing, there are many definitions, right? Because some people call an API test that uses the actual dependencies like the database or the API running or the messaging queue running as an end-to-end test because it's like the API is also an interface. So there might be different opinions on what an end-to-end testing is. But for this context, I'm going to say that an end-to-end test is something that uses a mobile app or a web browser, and therefore all the stack from the way down. The idea of this section is, that end-to-end tests should be the least amount of the whole stack, but they should be covering the most important user workflows that you have in your business cases, in your web applications or your mobile applications. This means that you don't need to have 200, 300, 500 tests to verify that everything is working. This was a very popular thing years ago. It was very common to go to a Selenium conference and see people doing presentations about, I run 1,000 tests in 2 hours every single night, and my web application is completely bug-free. That is not true anymore because web applications have evolved a lot, and also because there are more ways of testing a complete tech stack, right? Uh, so what is important these days is to identify very important workflows that your application has, what the user should be having always as a working piece of software. And then those are the flows that you should be always testing, plus some extra corner cases that maybe you think in your test strategy that this is important for you. And then what you do here is that, for example, I have my web application, and I need to make sure that my web application works in all 4 major browsers. I need to make sure it works in Firefox, in Chrome, in Microsoft Edge, and in Safari, right? But maybe it's not enough to do that. You also need to check that it works on Linux, Mac, and Windows. And if you have good analytics in your website, you need to make sure what else? That not everyone has like a 27-inch screen. They also have like smaller laptops. They also have like mobile browsers. You need to run those tests as well in different resolutions to make sure that the application renders properly, that maybe when you have like a bigger font, it doesn't overlap other section of the page and so on. So that's why it's important to have the really important user flows, and also to basically make sure that they work well in every single browser combination that is meaningful for your customer base. Then when we talk about mobile applications, we can also consider the mobile browsers. So coming after the concept I just shared with you, which is please test all your vital and super important user workflows. If you don't have access to real devices, you can start with emulators and simulators, because sometimes maybe you have just like 5 or 10 real devices, but you need to test many different changes in the application because maybe you have like different teams making changes and so on. So what you can do is that you can enter into the emulator simulator spectrum and use them for CI/CD speed. So you actually are sure that the changes are working well on different browsers, on different resolutions, and on different operating systems as well. Now, if your focus is mobile applications, obviously, this is the way to make sure that the changes that are not fully complete are working on vanilla versions of operating systems in the case of Android, or devices that are like easily accessible, like the simulators in iOS and the different versions of it. So for example, if you want to make sure that if you see that your customer base is using still like iOS 16, iOS 17, and maybe some of them iOS 15 because they have not upgraded to a higher version, or maybe their device is not actually upgrading, you can still make sure with this lightweight of not embracing into the full real device ecosystem, um, to be sure that your application is still working well. And I think it goes without saying that when you want to verify the real deal, that's when you need a real device, because you need to know the network conditions. You can tweak the settings and make your real device to simulate that there is no network connection, so you can verify how the application behaves when there is no connection. So maybe when the user is going in a subway, or when the user goes and takes a flight and wants to see some content offline, things like that. That's what you can do. And in addition to that, in some cases, maybe you have made changes to the application. Maybe you have a new SDK under the hood that helps you render content, and you're not sure if that SDK is gonna be better performant or not. And then you can check how the device is behaving in the CPU, in the memory, how the battery is performing, and if you're also willing to check if the web or mobile application is behaving properly, depending on every single change that is happening, you can do visual testing as well. So instead of like writing very extent tests, you can do a few user flow steps, and then take some screenshots to make sure that the workflow is still working well, even though you don't need even though you are not like writing a very detailed test. That was the top of the pyramid that we know. A few interesting things that I learned. Well, I didn't learn, but I didn't consider as to be part of the pyramid, and they are, the human element of the test pyramid. And this is something that unfortunately doesn't it's not covered as a whole. Like many people think, or maybe many people talk about these topics like exploratory testing and clean code on the side, not really as part of the automation world. And in this case, I just want to hear from you, if you want to comment in the chat box. How often did you do exploratory testing? Because I think, at least when I was a tester, we were very much focused on the automation suites, that they were like working well, that they were being executed like every couple of hours. In some projects, they were being executed on every commit. So in those cases, we were extremely focused on the automation code, making sure that it was working always. And I believe that we were not paying much attention to the exploratory part. And I wish we did more on that when I was being an automation tester a few years ago. So I want to read from you if you spend some time doing that, because I think in this area where we see so many new things about AI, that promising that they're gonna like write your tests, that they're gonna maintain your tests, that they're gonna like heal whenever a test is failing. Um, I cannot imagine that there will be a tool that is able to do exploratory testing for you, because to some extent, understanding if an application is usable, if it's flawless, if like maybe in some case doing one extra click is easier than filling an extra long form and just one single click. Those things are very hard to determine by a machine. So I think that this part, I wish it was more connected to the automation world, that what we currently see. So on top of the pyramid, please always have like some good exploratory testing, and as well some clean test code. Um, I think it goes without saying that clean test code means that you have code that is easy to maintain, that is easy to work with, and additionally that when you have the need, or when you have the need to change to another framework, to make an upgrade, to maybe change locators, that the abstraction layers that you have in your code are simple to understand, that you can make changes in a simple way, and they don't actually give you too much trouble. So making changes is actually more complicated than maintaining the whole test suite. To start wrapping up, what I wanted to share today was this, that there is a test pyramid that is very like it is very practical, but it still tells us the basic things, that there has to be a balance. We need enough things at the base and the middle layers, and hopefully at the top layer we leave um, the most important and interesting user flows, that we can multiplex them with different devices, with different operating systems, with different browser versions, and different operating systems on the desktop level, and so on. So one of the things that we tend to do often is that if you're a customer that needs some sort of like professional advice, let's say, you can always contact your CSM and ask for that, to see if there is a need for like, okay, is my test strategy correct or not? I need like professional services, something like that. There are different people at Sauce Labs that are happy to collaborate on that, and then it's a conversation between those three roles, like you and your CSM and some folks at Sauce. This is mostly what I had for you.